I remember how I said listen up, please? I want your control. We close the door. Thank you. All right. Just waiting for you to settle in. So I hope that you guys are doing well. We have a full week this week. There's tutorial and flex Wednesday and Thursday. There's a leap. It's a leap year, so there's a February 29th this year, which I'm kind of pumped about. We have a full week this week. We'll talk about this calendar tomorrow when I have the calendar. I gotta get my 2016 calendar, but I'm getting it today, so no stress, no stress. Okay, so as for the rest of the week though, here you go. You'll notice that that's some weird homework assignments. You have a quiz on Friday. So go ahead and fill out those planner sheets, please. Just update your workbook, please. That's all I'm saying. Those of you who are done, do this as well. Today we are going to front load a lot of information. There's going to be a lot of vocabulary today, a lot of definitions today, a lot of notation today. Is a way of writing things. We're going to do all that, so that we don't have to do it for the rest of the unit, really. Okay, because once we have all these definitions down, and kind of can start to build an understanding of what I'm talking about, then we can use it, right? So first we're going to kind of take some time today, we're going to go through all those definitions, and we're going to talk all about the properties of quadrilaterals, and parallel lines, and all this junk, and then we're going to start using that. Like on Wednesday for math, we'll be outside doing a group task most of the time, and similarly on Friday. Okay, so today's going to be a little bit, got a lot to get through. That's what I'm saying. Also, that being said, if you don't know the definitions today, if you check out and aren't following today, you're going to be ruined for the rest of the unit. Okay? Because, definition is just something that I expect you to know. And it's not so if you don't know it and you're checking out and you're not trying to make any connections to your brain so that you can know what I'm talking about, then you're going to have a tough time. Okay? So, just so you know, that's what's happening this week. We did this, yeah? You guys updated? Again, I was telling third period, so I'll tell you. Like, for instance, tonight's homework, sometimes you guys do this. There's been a few of you in here who've done this. When I go to check off the homework, you just do 19 through 24, and then I go, hey, where's 26? You're like, oh, I thought it was just 19 through 24. I'm like, no, it says up there 26. And then you go, well, I wrote down 19 through 24, and I can see that you've erased 26. Like, you think that it would matter to me, or that I'm stupid enough to believe that was an honest mistake. I'm like, you're lying. Like, what are you doing? So I don't care if you write it down wrong, just for the record. Like, you can write whatever you want. This is what the homework is. So if you don't do it all, don't try and erase it like you think you're sneaky. Like, that just makes you look weird. Like, I'm like, you just kind of look shady. Okay, anyway. Yeah, like, why are you trying to pretend like you didn't know and you erased it? Like, what's wrong with you? That's silly. Anyway, few people have done that. Yeah. And they don't get away with it. That's just awesome.
Has anybody got away with it? And you found out they got away with it?
No, if you don't have 26 done, I can pretty clearly see it. Okay, here is the next thing. You guys were fabulous on Friday. We finished all 4 walls, which was big time. That was great. Now we're going to start on 4 more walls. No, I'm not. Okay. So, here's the deal. You might want to pay attention. because especially those of you in the back half of the room, I'm going to be asking you to calculate this tomorrow when we're building this wall. Here's the wall we're going to be building. There's a window in the middle. That's not true. Sorry, just ignore that part. There's not a window in the middle. There's a door. There's nothing. Never mind. Okay. There's a door and a window that aren't in the middle. Okay. Here's our wall. We talked about a lot last week, right? We talked all about this idea last week. Tommy, please pay attention. That this stud, if it was the 4-foot stud, right, had to be offset. We had to take into account that 3.5 inches for the California corner, right? So when we were calculating that stud length, that it wasn't really 4 feet, that we had to think about that 3.5 inches, right? Here was the drawing we talked about, right? So when I was trying to calculate that wall, I had to consider the 3.5 inches of my front wall of that California corner. Yeah? Remember we talked a lot about this? Okay. So here is the deal. That's super important because of that 4-foot stud, because of when we put up that siding, it needs to be in the right spot. Now, for our in-between studs, our 16-inch stud, 32-inch stud, and then we get to the 4-foot one, so there's going to be 2 in between there. That one doesn't matter as much. So this 16-inch stud is we're just going to go 16 inches from the outside of our wall. Okay, so I'm just going to make that 16 inches. So calculating these lengths is a little bit easier. A little bit simpler, because you should already, looking at this, and those of you in the back, you should already know our pitch triangle or our slope triangle. And all of you should know it really, but like you guys should extra know it. And it's obvious. That's weird to say. It's fairly easy to get from looking at this, right? From 6 to 8, what's the rise? Yeah, 5, and then the run is 10, right? So it's a 2, 10, and I'm already giving you, there's no extra calculation needed for that 16 inches. You already know the bottom of one of your similar triangles, right? So you're going to be comparing that 10 and 2 to the 16 and X. It already tells you what you're comparing. My question this right now for your warm-up is, what's that length? What's the length for that 16-inch brace or stud? What's that? So, freeze on. Thanks. Yeah, I got you. Okay? What's that length? Calculate that length now, while you have out 13 through 18, please. Third period. The question came up of why do so many people hate math? Easily one of the most hated subjects across the board. And I think there's a multitude of reasons for that. One of the reasons, I think it's because there's a bigger issue socially, culturally, where it's okay if you're bad at math. Right? Some of you probably have parents who are like, I'm bad at math. So of course you're bad at math. I've had parents say that to me, like, I'll be talking about your grades, and they're like, well, I'm bad at math, so of course they are, because it's genetic. I'm like, that's not, no. That's one reason. That it's like, it's kind of okay that people are like, yeah, I'm bad at math. I tell people I'm a math teacher all the time. People are like, math, like, I just don't get it. I just don't have to get it. Where the flip side, right? No one says that about reading. You're not just like, I just can't read. It's cool. It's all good. Or if you said that to your parents, if you're like, I just don't get reading, they wouldn't be like, that's okay, you don't need it. Right? They wouldn't say that. And I'm not necessarily comparing their importance either, because whatever. But, so it's kind of okay. That's one reason. The second reason why I think a lot of you guys, not necessarily you guys, but in general, people don't like math, is because it actually requires something of you. You can't just like absently memorize some stuff or just look it up. Or you actually have to engage, and that shuts a lot of us down. And couple that with the fact that it can be challenging, and that some of you guys have had some pretty bad experiences where you were made to feel like makes you feel dumb, then of course you don't want to engage with it. But the truth is that math, it does require you to be present. It requires you to be thinking, and it requires your brain. So you can't just absently sit there and like get math, right? So some of you guys who right now, and this is why I'm bringing this up, because some of you guys right now, I gave you this warm-up, you drew this, great. You maybe even drew a pitch triangle, great, and that's all you have on your paper. Because from there, once you have this drawn, now is when your brain needs to kick on. You actually need to think about something, and some of you didn't make that jump. Instead of that, you just turned to your friend or someone next to you and you just started talking about random stuff because you didn't turn your brain on. Okay? Because ultimately, this is our third day doing this. We all have some access point. We all think about this in some way. But some of you just chose not to. And if you always just choose not to engage with math, then of course it's going to be hard. Of course you're not going to understand any of it. Right? So take a little gut check time. Maybe look at your agreements. Remind yourself, like, what is required of me again? Because some of you only have this on your paper. Unfortunately, you might as well have done nothing. Because you didn't do it. Like, I'm interested in your brain being active, not in the fact that you can write what I write. Okay, so if you're just going to wait until I write down the answer, you aren't going to learn anything. Because you're just copying. You're not thinking for yourself. Keep that in mind as we work through today. Okay? So, I'm not going to give you another chance, though, because we've got to go. When I'm looking at this, I've already given you one triangle. It's right here. I told you it's 16. That's your first triangle, right? So you're comparing this 16, this is x, and then you're also comparing your slope triangle. Your slope triangle is 10 and 2. And so those are the two triangles you're working with. We can get it even more abstract and stop talking about pitch on a roof, and we can just talk about it here as 16 and x and 10 and 2. Okay? So, of course, I would look for my multiplier. What's my multiplier? From 10 to 16. 0.6? 1.6. 1.6. So what's 2 times 1.6? So what? Oh, good. Okay. We'll talk about this. Some of you guys are saying we want to change. This is in feet. This was 10 feet and 2 feet. And we have talked about this in class, of changing it into inches. We're going to start to notice that there's a scale between one triangle to the other. We know this. We've done it a bunch of times. But there's also a scale between a triangle by itself, right? What's the relationship between 2 and 10? How do I go from 2 to 10? Times by 5. So let's say I turn both of those into inches. Okay, let's turn both of those into inches. Can you see my times 5? 10 feet is how many inches? 120. And 2 feet is how many? Anyone want to guess what 24 times 5 is?
96.
It's 120. Because the relationship, the scale or the relationship between those two sides of the triangle also has to be the same for all similar triangles. There's a few of you in here, in the mix, who have heard from maybe a tutor or another math teacher or someone that you do these differently than I do, because you look at the ratio between the two sides. Because there's a scale from the small side to the long side, it's 5 times bigger. From the small side to the long side, it's 5 times bigger. So that's one way I could go about finding this missing side. It doesn't matter if it's in feet or inches. That's what I'm saying to you, Eli. It doesn't matter if it's feet or inches. The scale is the same. They're similar triangles. So it doesn't matter. Yeah. Yeah. Yes. Yes. You can find the ratio, like you're saying, Chris is saying he finds the ratio between these sides. The other way you can look at it is there's a bunch of ways, and let's throw on because we've done a bunch of these. If 2 times 5 is 10, how do I go backwards from 16? Yep, divide by 5, and I get 3.2, which, if I had done 2 times 1.6, I would have got 3.2. It doesn't matter which way I look at this. It doesn't matter whether I go from the short side to the short side, or if I go within the triangle itself. There's all kinds of relationships here that you can use. The important thing to know is that if you go outside tomorrow and you tell me cut it at 3.2 inches, we've got all kinds of issues. The first one being that I can't cut 0.2 inches. What do I gotta do? Turn it into a fraction, and we're talking about fractions of what? Fraction of a what? Of an inch. So inches are broken down into what? 16ths. So I need to turn 0.2 into 16ths. Oh, that's weird. Great. So it's 0.2 is about 3/16. So this is really going to be 3 3/16 inches. 3 3/16 inches. You have a question? Let's do it again. I found out that side was 3.2 inches long. I can't do 0.2 of an inch though. That doesn't make sense. So I know it's 3 inches, and I need to figure out what fraction 0.2 is. So 0.2, when I'm talking about the fractions of a 16th, I want to know how many 16ths does that 0.2 represent. When I do that, I get 3.2 16ths. It's confusing because that's the same number we got before, but that's just a coincidence. So it's 0.2 is 3/16. That's what I'm saying. Okay, now again, still an issue. That's not how long the stud is. Because what? What are we forgetting? Yeah, we need to add on the rest of it. We need to add on this piece. Do we know how long this piece is yet by memory? It doesn't sound like it.
Wait. Before you come up with the link.
Talk about this. Wait, I heard it in the back. What? 67.5, because in the back we've been calculating these lengths for a long time. So I need to add this to 67.5 inches. You go ahead. Add them up. 30 seconds in your table right now. What are these? What's 3 3/16 more than 67.5 inches? Ready, set, go. In your tables. 30 seconds.
That's right. Let's go around.
All right, that was your time. What did we come up with, Kenya? You guys agree? 11, 8. Did you guys do it like this, that a half is 8/16 plus 3? Okay, cool, great, gravy. Okay. So, you would cut it at 70 and 11/16 inches. Oh, that's all I am. Okay. You had 6 homework problems. They were pretty short, pretty easy. You only get 4 minutes to talk about them. Like I mentioned to you on Thursday, in this 4 minutes, I don't want to hear any other conversation. If you don't have any math to talk about, then you don't get to talk about anything. 4 minutes. Tommy, please don't do that. Of only talking about math, 13 through 18, making sure you all at your table agree. Got it? What if someone at your table is asleep? Wake them up. What if someone at your table didn't do their homework? Who can tell me what's a good thing to do? Mariah.
You gotta ask questions so you can make sure you understand even though you didn't do it.
Cool. If you didn't do it, ask questions so maybe you can understand how to do it. In the very least, you can write down your answers. And these problems, you can probably do them as quickly as your table talks about them. I bet the homework assignment only took about 5 minutes total anyway. Okay, so 4 minutes, only math. Look at your agreements maybe. Remind yourself of how your team has agreed to operate your norms. Ready, set, go. Isosceles triangle is when the non-parallel sides are the same length. So isosceles trapezoid is is the nice kind of trapezoid. It looks better, more pleasing to the eye, instead of all willy-nilly like the other ones. There's the angles. 17 I'm going to talk about. 18 was the cross race. Major questions here? No, not you, Major. Just like, are there big questions? Yeah, no, yeah? What? You didn't understand the question, Sean. Are you awake? Because, do we not know what a perpendicular bisector is? Okay, again, I told you there's going to be a lot of vocabulary today. A lot of new words. What does bisect mean? No. What does bisect mean? To cut in half.
Oh, you go now.
I think this is how I die. Oh, God. That's how it ends for me. Okay. A bisector perpendicular means 90 degrees. Bisect means cut in half into 2 equal parts. Perpendicular, 90 degrees. Bisect, 2 equal parts. So that's what you're looking for. On 17, you probably already said something like this or wrote it. All of you need to open up to 17 in your notebooks right now. We're going to put some notes on number 17. You could do it in your notebook if you just absolutely had to, but we're just going to do it right here. Okay. On number 17, it's asking us for pairs of congruent sides. And I already had it written on this. And we all probably already noticed that this top side is congruent to the bottom side, yes?
Yeah.
Cool. Here's how you are going to write it henceforth. From now on. I would say that AD, and I mark that it's a side by putting a line over it. So side AD, this is the new piece we're talking about, is congruent, you already know that one, to side BC. Instead of writing AD and BC or whatever, this is just the way we're going to write it. So from now on, when we're talking about congruent sides and angles and all that jazz, so go ahead and take a minute right now, because I don't think any of you wrote it this way, because why would you have? We hadn't talked about it. And do that for the other set of sides. Try writing it out in the correct notation for the other set of sides. So if you wrote it for both sides, again, it would look exactly the same, except I'm now saying that side DC with the line over it is congruent to AB with the line over it. Also noticing, yeah, you have to use capital letters. You know, I mean, that's just the agreed upon way of writing. So, similarly, it asks for pairs of congruent angles. And I already have them marked that A and C would be congruent, and you hopefully said the same thing, that A and C are congruent and that B and D are congruent. In order to write that though, to write that A and C are congruent, I'm going to write it like this. I'm going to talk about it being the measure, so I put a little m, of the angle. The angle sign is flat on the bottom, different from a less than sign. It's not the little alligator talking about the angle. The measure of angle A is congruent to the measure of angle C. I'm not writing an L, and I'm not doing the crocodile. I'm writing angle. The difference between angle and crocodile, ever so slight, but we're trying to exaggerate it, is that I'm talking about an angle with the bottom is flat versus where, you know, it's in the middle, right? It's not like that. It's flat on the bottom. Okay? So there is a difference. Let's try and mark that difference. Same thing. And we're talking about the measure of the angle because we're talking about the actual degrees of the angle being the same. So the measure of angle A, measure of angle C. Go ahead and again write that the other two angles are congruent using that new fancy pants notation. You were absent. Sucks.
Whose birthday?
What?
Friday? No. It's like a month. No, nothing. Oh, that was supposed to be.
Who's that for?
Metal's not here. I see every needed one.
Huh? Who are you saying? Okay. Ooh, that was a minute instead of 45 seconds. Okay. Now, oh,
Right, do it. It's your book. No, it's mine. What are you doing? No. I got something we need. Oh, Ah! all the time. It's more like right.
I'm sorry, I'm sorry.
You're trying to measure this length for all the sides? You're trying to measure the angle?
You ever like collide tables? Make them like line them up. Yeah, that would be, I think that would be.
No, I'm asking about what Hey, last comment I want to make real quick. Some of you guys are asking about opposite sides or opposite angles. Don't think like SOHCAHTOA. Some of you are wondering about like where's the adjacent side or where's the opposite side. Like just simply opposite angles are opposite each other. Okay? So like this angle is opposite that angle. That are opposite because they're not touching in any way. That definite, like very simply. So don't think too hard about like, well, is it opposite which angle and what side? It's just there's two opposite angles and there's two opposite sides. Okay. So finish up. I'm gonna give you 3 more minutes. Go. Goes away, please. Don't put that by your mouth. Don't do that. This is as close as we are gonna get to a lecture in this class. And really, I'm hopefully just reviewing with you what you already know. That's kind of the goal here. We already talked about a square. Before I even start talking, actually, I should also say that we're going to be talking about 2 things. These are an important distinction. There's a difference between the definition and properties, right? For a square, what's the definition of a square? This is what we wrote down in our notebooks quite some time ago. Definition of a square. Mariah, you got it? Okay, a quadrilateral with 4 congruent sides, 4 90-degree angles, right? So all the sides are the same, all the angles are 90, square. Now all this other stuff, these are properties of a square. These are things that because all 4 sides are the same and because the angles are 90, these are things that follow. They're properties that happen naturally as a result of that definition. Do you see what I'm saying or no? Some. Okay. We'll keep working on it. So again, like here, the fact that the opposite sides are congruent, here's the definition part of the square. The fact that the opposite sides are congruent and that the adjacent sides meet at 90 degrees, those are the definitions of a square. That's by definition, that's true. All the other purple stuff I wrote are the properties of a square, right? The fact that the opposite sides are also parallel. The fact, I'm sorry, that's a definition. I lied. That adjacent sides are congruent is a definition. But the fact that the opposite sides are parallel, that's just a property of a square. And the fact that the diagonals are equal, or that they split each other in half, or that they meet at 90 degrees, right? No, it's not. That the diagonals meet at 90 degrees.
Oh, not that.
Yeah, yeah,
Oh, you just-
yeah. The diagonals meeting at 90, right, is then part of properties of a square. The square, we're okay with these? Do you guys agree with me? Here's the deal. I might be wrong on some of these. I didn't measure. It just kind of went off my memory. So I need you to... No, I'm not learning it though. Yeah? So here's the deal. Because again, yeah, I know, it's crazy. I want you to think for yourself. What a wild idea. I do. So just checking that these are correct, right? It's on you if they're wrong. That's all I'm saying. For a rectangle. For a rectangle. Again, the definition of a rectangle. This is it. That's the definition of a rectangle. That's all we have as far as the definition is concerned. But all that other stuff, right? All that other stuff is the properties of a rectangle. So by definition, a rectangle has 4 90-degree angles. The sides are perpendicular to each other. They meet at 90 degrees. That's the definition. And then we can also see that that forces the opposite sides to be parallel each other. And it makes the diagonals bisect each other. It splits the diagonals perfectly in half, and the diagonals are equal. But no, it's also obvious that the diagonals are not perpendicular. They do not cross at 90 degrees. Pay attention real quick. I asked, okay, a little story. Mr. Horseshoe and I did not teach tech geometry last year. We didn't know this. We didn't teach it last year. So we have a group of kids in tech algebra who we didn't teach last year, right? They were their own tech geometry class. Okay. And I asked them something today that I hope that kind of made me sad. And if I ever ask you, I hope that you can answer it, because this is a must be able to answer. Looking at this rectangle, looking at the boxes you guys made at your tables, how do I know if it is square? Not a square. Not a square. It's obviously, this is not a square. It's a rectangle, right? Remember we had that fun little argument? No, is it square though? Are those 90-degree angles? I know something is square if I should be able to call on any of you, so don't raise your hands, because I'm going to call on someone right then. Are you ready? Do you want to have a conference at your table before I call you randomly? You have 10 seconds at your table to decide how you know if that's square. I'm going to call on one of you, just so you know.
Who?
How do I know? You could check right now if the box on your table is square. You didn't make those boxes. Check it. How do I know? You don't have a speed square. How do I check it real quick? Telling me this. Who do I? Max! Ah, both of you. I call you Maximus because that's what you told me. Max, how do I tell if it is square? I like that you're talking about these. We're close. Talking about these. These are the what? What are these called? The diagonals. If the diagonals are what?
The same length apart.
Congruent. The same length. Hint, you're going to need that on Wednesday. I'm telling you now. Okay. You're not going to know why, but it'll come full circle. It's like I'm just planting the seed.
Is this paper spoiled?
It darn well better be. If something has 90 degrees in the corner, the diagonals must be equal. Okay? The diagonals must be equal. Must. Must. That's how you know. Notice none of the other shapes, right? If it's a parallelogram or a trapezoid, right? Then its diagonals are not equal. Okay? Alright. That's a rectangle. And the diagonals bisect each other. Okay, great. Moving on. Parallelogram. Parallelogram. Looking at it, by definition, that's the definition of a parallelogram. That the opposite sides are parallel. That's it. That's the definition. But I can also observe that since the opposite sides are parallel, that also makes them congruent. The two pairs of parallel sides, it also makes them congruent. Also worth noting that opposite angles on a parallelogram are congruent. The opposite angles on a parallelogram are congruent, and the adjacent angles add up to 180. We're going to see more about that. And the diagonals, right, if I measured, these ones I measured, my diagonals are not equal. One was 4, one was 5 and a quarter. And a half, just kidding. Okay, my diagonals are not equal, but even though they're not equal, they still split each other in half. They still split each other in half, but they do not cross at 90 degrees. Okay, this one you might think it looks close, but here I drew two really weird parallelograms where you can see clearly that they don't cross at 90 degrees, right? These ones are clearly not equal. These ones clearly not 90 degrees. Okay. Questions so far? Okay. Starting to get weird. Isosceles trapezoid. One set's parallel. Tommy, just because you don't think anything I say is funny. One set's parallel, and then these are the other set is congruent. One set's parallel, the other set's congruent. Again, those are both definitions of isosceles trapezoid, and like a regular trapezoid, the opposite angles here are supplementary, and the adjacent angles are supplementary. All kinds of special things. Sorry, that's two. Okay. Now, your last one is a rhombus. You should have got the same. Oh, I didn't finish a rhombus. I didn't know. Someone tell me. Did they bisect each other? Yes. Right? Were they equal? Hey, what'd you get right here? You got yes. The diagonals are not equal on a rhombus. No, it's not equal. Also, are they perpendicular? Did you guys get no? I say no. Okay. Now, here's the fun part we've all been waiting for. As soon as we started talking about quadrilateral, does anyone remember when I said rectangle, then I said square? What was the first thing one of you guys said? Yeah, look, rectangle this, square's that. Remember? You guys have done this like 3 times to me this year. So, here's how it goes. A square, let me check, hold on. Shh. I said it wrong last class. A square is a rectangle. See or no?
No.
A square meets the square definition. What's the definition of square?
The definition of a square is a quadrilateral plus 3 sides and 4 angles.
Cool. 4 90-degree angles plus, check it out, hold on. You're going to be doing your own in a second. 4 90-degree angles plus 4 congruent sides. So 4 90-degree angles, which is also the definition of a rectangle, meaning a square is a rectangle on steroids, right? A square is a rectangle that also has 4 congruent sides. So a square is a rectangle, but a rectangle is not a square because it doesn't have 4 congruent sides. Okay? What? Okay. So here's what you're gonna do. you're going to make your own. A blank X is a Y, but a Y is not an X. You are going to make your own individually. You are not going to talk to your team. But using those properties of these quadrilaterals, just like that rectangle square one, you're going to think of, okay, what shares a property? What goes one way but doesn't go the other way? Like a square could be a rectangle, but a rectangle is not a square. You are writing your own. You have 1 minute. You may not use my square one. Now, next step, step 2. Hey, Eli, alto. Next, you are going to vote on the best one from your team. You have only 15 seconds. Go.
I think
Yeah, because a rhombus. Yeah, that's why a square isn't a rhombus. A rhombus has a quadrilateral with 4 congruent sides.
Yeah, but if a rhombus is a square, it would
And then a square isn't a rhombus.
Heat. So you might need to have some backups. And your job as a class, your job, not my job, is to determine the validity of these statements. Now I realize I say a lot of weird words and some of them aren't real words. This is a real word. It means you're determining whether or not it is valid, which means whether or not it is true. Okay? So validity is a real word, just to be clear. Okay. You're determining the validity of these statements. Would anyone like to volunteer to go first so that yours doesn't get stolen? Kenya. Brutal. All right. So, do you guys agree?
Indeed.
I can't do it with all your hands up, so put them down. Put your hands down. Put your hands down. Who's next? Sam. Duke. This. Hold on. Why? I don't know why this is so challenging. Is this true?
our face is telling me it's not true.
No, I'm not sure. Does a rhombus have opposite sides parallel? Yes. But a parallelogram doesn't have all sides congruent. Yeah, that's cool. Cool. Next. Dahlia. If you guys would shut your mouth. Notice my shorthand, by the way. Feeling pretty good about it. Rectangle versus parallelogram. Hold on. Shush. Is this true? Hold on, actually, we're gonna cut out the verbal response. Thumbs up if it's true, thumbs down if it's not. You can do middles too if you're not sure. I'd rather have you vote. Okay. Eli, what do you think? No, for this one. Okay. Why? That wasn't the one you were voting on? You thought I was talking about this one? Okay, hold on. I want to say 2 things. First of all, we're going to... Hey, eyes up here, please. We're going to talk a little bit about logic in these weeks to come. And one thing I have to point out is we all kind of giggled, and I hope, you guys take this. Because if I said, Eli, is that true? And he said, yeah. And I was like, all right. You should never believe someone just because they say, yes, it's true. You should at least ask why. Right? Is that true? If you're like, yo, this is true. You're like, okay. They said it's true. Same thing we're talking about, right? The whole reason you guys are measuring and coming up with these. So that if you ask why, he said, because again, like, and he was just kind of, we're just going with it. It's not a very good reason. Like, hopefully they're real because, and then he was honest and said, I didn't think through it, so give me some time. But he thinks it might be true, but he's going to think through it a little bit, like an informed citizen. Or just vote willy-nilly.